Welcome everybody to take control of your multi-cluster, multi-tenant Kubernetes workloads. This is a talk we're going to give today about dealing with Kubernetes in kind of enterprise deployments where you've got lots of clusters, lots of tenants, and in particular, we're going to talk about the GKE policy management alpha that we announced here today, and then we'll be demoing that in the end. My name is John Murray. I'm a product manager with Google Cloud. With me is going to be Colline, who's one of the lead engineers on the project. So up front, we're going to go through some of the principles that we were looking at. We were trying to deal with some of the problems around managing multiple Kubernetes clusters and dealing with the multi-tenancy issues that arise from that when you're thinking about policies, access control, quota limitations, and those sorts of things. So we'll walk through that. Ray will spend some time walking through the architecture and some of the features that we have that we're debuting here in the alpha, and then we'll do a demo for you at the end. So to start it off, I want to talk about just generally the problems that we see when we talk to customers who are really looking to scale up their Kubernetes deployments. And these are administrative problems, right? They're the problems of operators in dealing with how do you get a bunch of development teams onto your Kubernetes infrastructure? How do you make them productive while ensuring that things are secure and that you're keeping an eye on all the administrative things? So when people start out with Kubernetes, this is usually what we see. These sort of cluster per tenant scenarios, where you have one tenant, in this case, right, a dev team, the blue team, and they want to play around with Kubernetes, they want to experiment with it, so they go and spin up a cluster. And that's very easy on GKE, but it's also very easy to spin it up using some tooling or to work with any other cloud provider. And once you have multiple people doing this, now you have a number of these cluster per tenant scenarios within your company. So you have one tenant, they have their own cluster, they start running their pods in the default namespace, and that's fine. They have isolation because that cluster is the boundary for them, and it's not necessarily administrative hassle. But if this scales and you've got 100 of these clusters running with 100 different tenants, all running their clusters different ways, then it's hard to think about normalizing things like access control across them. It's hard to deal with upgrades, it's hard to deal with versioning, it's hard to deal with all the sorts of administrative tasks that you have to manage. So the next phase of the evolution that we see people go through is that they take that tenant and they provision them a namespace across multiple clusters. And so now you've got, say, 3 clusters running. Maybe you're doing that because you need clusters in each region, close to where your users or your workloads are. Maybe you're doing it for redundancy. There's a number of reasons why you might want multiple clusters. If we give a namespace to the blue team in each one of those clusters, then they can run their pods there, and we can attach policies and to access control, quota control, network policies, et cetera, at the namespace or at the cluster levels to kind of normalize that. Where it really gets tricky is when you have multiple tenants across multiple clusters. So in this case, I've got 2 tenants, a blue team and a green team, each with their own namespace in all my clusters. But in a real life scenario, you may have hundreds of these tenant teams, each with their own namespace, and you may have dozens of these clusters. And so the scalability problem becomes in how do you manage the policies across all of these? Because each of these Kubernetes clusters is somewhat of an island when you're talking about policy management. Setting up the namespace definitions, setting up role-based access controls for each of these namespaces, and ensuring that each of the namespaces looks the same across all the clusters so that your development teams don't have to deal with variance across that workspace. And today, people are managing that in a number of ways, but it's a lot. And so we see over and over again, as people scale up from experimenting through Kubernetes to dealing with it at scale, this is a point that they end up with. And maybe they try to manage it with scripts, maybe they build their own tooling, but it's something that we wanted to take a look at and say, can we, as Google, come up with something for the Kubernetes community that helps deal with this particular problem? And so that's what we're going to talk about with you guys today. Before we get into the nitty gritty of the details about what we've built and what we're doing in the alpha, I just want to talk about a couple of design principles that we use when we were looking through how to deal with this problem. So the first one is that we didn't want Kubernetes clusters to be islands. Right now, there's very little federation support in Kubernetes, and so if you're running dozens of clusters, you're often interacting with them one by one, loading them all up into the context of your kubectl and switching around, scripting against that. But automation here is really the only way to manage this as a sane way across a lot of clusters. So we wanted to build tooling that works in this cross-cluster environment and provide some centralization so that you don't repeat yourself over and over again when applying policies. The other thing we want to do is create a clear separation between infrastructure and tenancy. So the analogy here is like an apartment building, right? You start with an empty apartment building like an empty cluster, and you need to set it up so that you can bring people in and have them move into the apartments. And that's things like setting up the infrastructure, the plumbing, the heating, the electricity, but it's also setting up a lease, right? What are the terms of your tenancy? What are you allowed to do? You're not allowed to play death metal at 2 in the morning. You're not allowed to hang out naked in the hallways. You need to be a good tenant. But within the concept of, within the constraints of your apartment, you're allowed to do whatever you want. You can hang up whatever posters you want. We're not going to tell you what couch color you need to do. We create a safe environment for you where things are clearly delineated. The administrative things are for administrators, and dev teams are freed up to do what they need to do in an agile way. And the last principle is policy workflow. So we can automate policies, we can centralize policy management, but we want to make the actual application of those policies easy to manage. And oftentimes, when you're talking about scaled up infrastructure, you've got a team of people who are doing administrative stuff, setting policies. And so we wanted to build workflow around the changes that happen, around the definition of those policies, so that administrators could cooperate with one another, review policy changes, think about policy changes in the same way that you think about code. You can roll them back, you can do reviews, you can edit them, and have auditability around changes that are made there. A lot of the things that we take for granted, when we're talking about source control, we wanted to bring some of that goodness to policy management. So those things we were thinking about as we were looking at building something. We spent the last couple months here getting it ready and bringing it out to alpha. So please welcome to the stage Ray Colline, my colleague. He's an engineer on the project, and he's going to walk you through Kubernetes policy management.
Cool. Thanks. Thank you, John. And again, I'm Ray Colline, and I'm a software engineer who thinks a lot about policy management on Kubernetes. So today we're going to actually be getting in to talk about what did we do for this alpha, and what are we going to be doing kind of going forward with this, and where do we see it going, and how hopefully it can help you. So the first thing I want to say is that this is just one part of a much bigger story that we've presented here at Next. And importantly, with the hybrid story, you'll see here that policy management, which is down at the bottom, fits into the overall kind of on-prem, GKE, managed Istio. We want to have a way of dealing with all these things from a policy perspective, whereas the analogy that John used, thinking about the building owner in this case who's trying to lease out these apartments which have all of these particular features. So when we think about policy management specifically, we're thinking about centrally defined policies in a source of truth. So you want one place to go look at that you can say, here is all of the tenants in my environment across all of my clusters. And that know that when you submit and put changes in that source of truth, that it applies across all of your clusters. And so we're really doubling down as namespaces in Kubernetes as the minimum level of tenancy for defining this. And you can think about it in terms of the analogy is that namespaces are really those apartments that you're leasing out. And so with this central policy store, you can manage things like RBAC and quota policy and more, right? And that more is coming. Okay, so I mentioned the idea of sources of truth. What I'm going to try to do now is detail kind of how the components of GK policy management work, and kind of the concepts that we've introduced. So it starts with the idea of a source of truth, which is that place where your policies are defined. Now in the alpha, I'm going to talk about two particular sources of truth that we support today, but the intention is to be able to build arbitrary sources of truth to meet customers where they are. And we know a lot of our customers end up creating their own policy stores and they want to figure out how to make that work with their hybrid environments. And so we've designed that with this in mind, where one's going to be able to write a component to read arbitrary sources of truth. And so what we've enabled in the source of truth is the concept of hierarchy. So now, today in Kubernetes, namespaces are flat, and then there's a cluster on top of it. And you can basically set a cluster-wide policy, or you can set a per namespace policy. But in many organizations, they want to actually group namespaces and then apply policies to a subset of namespaces. So in GK policy management, we support the concept of a group of namespaces that have common RBAC policies and common quota policies. And so with that, what we've written, so we have that as the source of truth, and then within each cluster, so every cluster that's being managed by GK policy management, there's a set of components, controllers, that we install as part of the GK policy management install. And so I'm going to first talk about the idea of a policy importer. And so what the policy importer is responsible for is reaching out to that source of truth, whether it be Git, whether it be GCP, whether it be a MySQL database, and reading the policy data and putting it into the cluster as a set of CRDs, or Kubernetes basically objects that represent the data. And then there's the syncer component, which reads those and is able to talk to the Kubernetes API server to create those objects. So we would manage things like namespaces, RBAC policy, resource quota objects, possibly limit ranges. There's a bunch of objects. And the idea of that separation is that the policy importer knows how to speak to different sources of truth and normalizes it to a format we understand, and then the syncer reads that format and realizes the changes on the cluster. And then I mentioned that we support hierarchical quota. Well, again, inside of Kubernetes today, there is no hierarchy. It's just flat namespaces. So we wrote our own admission controller, which understands hierarchy and can support oversubscription. And so now when you do, create pods and whatnot, you actually can control the number of CPUs at a group of namespaces level. Okay, so now I'm going to talk a little bit more about our sources of truth that we shipped in the alpha. So in the alpha, we have Git and we have GCP as a source of truth. And so I'm going to start talking about Git. Now, the reason we chose Git is because GitOps turns out to be a way that a lot of organizations think about managing policy. And the advantages here get to some of the idea of the workflow that John spoke about. Code tooling like Git supports the idea of pre-commits. You can do continuous integration, right? You can do code reviews. And so now you can think of creating an RBAC policy as a proposal or a merge request, and then someone then can approve it, and once it gets integrated. And then once it gets integrated, we automatically sync it down to the cluster and apply it. So this lets you use a workflow and introduce arbitrary levels of policy and meta policy into your management. So specifically with the Git source of truth, we've created our own directory format, which represents the hierarchy. And effectively, we use the file system, which is a very good natural way to represent hierarchy. And you'll see here in this example on the right, where you have foo corp, which is the root of the organization, and then underneath it you have online, and online's a department. And within online, you can have a series of namespaces, and you also can have an RBAC binding YAML. And so what we do is we use the same YAML you use in kubectl. So it's the same exact type of thing you'd write if you were writing kubectl, except you're checking it into a repo. And because it has the hierarchy, we'll actually take those RBAC policies and we flatten them to create the bindings in each namespace, giving the online admin the ability to see shipping app backend and shipping prod, etc. Okay. Now, what we also have is the concept of a vetting tool that makes sure that the integrity of this file system stays right. So if you check in random stuff, for example, if you create a directory under a namespace, that's not allowed. And so for us, what's really important is the question of, will it blend or will it apply, right? The answer should always be yes, and every time that question is asked, it's always yes. And so this is a really big deal in policy as code, because you don't want to check things in that get to the end of the pipeline and fail. Because when that happens, you're now stuck with a situation where your Git source of truth no longer represents the reality on the clusters, and then the operator right there, if they don't do anything, that stays persistent, and then you don't have a good idea of what's what. And then, or you have to revert the change and figure out what happens. So we spent a bunch of time creating a vetting tool that makes sure that the integrity of that tree is done, and that's part of the alpha. So anyways, once you commit, this stuff is connected to and grabbed by each cluster, and the policies are applied. Okay. Now I want to talk about our other source of truth, which is GCP. So within GCP, there's a hierarchy, and it's defined through the Cloud Resource Manager. And so the Cloud Resource Manager has the concept of an organization, which is the root. It has GCP folders, which are basically sub-organizations, and projects. Now, projects in GCP are the minimum level of tenancy, and namespaces in Kubernetes are the minimum level of tenancy. So they have a really nice relationship one-to-one with each other. And so what we've done here is we've said, okay, with an API that we're also putting out with the alpha launch, you can associate a namespace with a project. And so now what happens is that if you set IAM policies and you use cloud for IAM and you set it on a project and you associate that project with the namespace, we will synchronize the IAM policy to an RBAC policy on the cluster. So you can manage all of your access control policies, whether it be for using Cloud SQL or whether it's using Kubernetes, in the same place. And this even works whether you're using GKE or using Kubernetes on GCE or even using Amazon or another on-prem cloud provider. You can use the GCP hierarchy with IAM to manage those workloads. And so what this thing does is, one, it converts IAM policies to RBAC, but also does a compilation using the GCP Cloud Resource Manager hierarchy to provide the ability to do the subdivision of namespace management. Okay, so with that, I'm going to take you back to John, who will do a demonstration of what I just talked about.
Okay.
Thanks, John.
Before I get into the demo, I just want to set the stage a little bit. So Ray showed you a Git example a little bit earlier. That's what I'm going to walk through here and just kind of show you how I define some namespaces, how I set up tenants so that they can deploy their pods on the clusters. We'll talk a little bit about controlling quota, particularly controlling quota across namespaces. And then we'll set up a new namespace for a new tenant just to show you what that looks like. We'll do it across a couple clusters. The example we're going to walk through here is FooCorp. FooCorp has today, right now, an online division, and the online division has dev, staging, and prod set up as namespaces on all the clusters. That's the policy file that we'll be applying here. And then we've got kind of policies attached at different levels of the hierarchy here. Up at the top, we've got admin policies so that we can view the pods, set pod security policy across the entire organization. And then down at the level of the namespace tenants, we'll define the namespaces themselves, set up some shared resource quota as well as namespace level quota, and we'll set up a pod creator role so our dev team can show up and do what they do best, which is deploy applications. Can we cut over to the demo? Okay, great. So what you're seeing here is a tmux session. I've got a watch on the right side. That's a local repository or local version of the repository. It's actually hosted on GitHub and shows kind of the basic high-level policies that I've got applied across my company right now. So none of the namespace structure is in there. We don't have any namespaces specific to our development. I'm watching 2 clusters here at the bottom, just listing out the namespaces. And that's just the basic stuff that comes with Kubernetes, as well as our agents that are installed locally on the clusters. So let's get started. I'm going to look at this cluster here on the left with kubectl. And now I'm going to bring in a bunch of policies. So I'm just copying these locally from one directory to another on my machine. And you can see from the tree that now we're going to add this online division to FooCorp. Underneath online there, you've got shipping out backend, which is our service, which has 3 namespaces, dev, prod, and staging. All of those have namespace definitions, so they're just standard YAML. as well as some role bindings. So we've got the pod creator role binding here. You notice that's at a level above the namespaces. So that pod creator role binding will apply to all three of those namespaces. And the same is true of the quota there. So we'll be enforcing that quota as a shared pool of resources across the three namespaces. And then we've got kind of namespace level role bindings here for job creator and a namespace level role defined there. So that's kind of the initial policy state that I want on my clusters. I'm going to go ahead and make a commit here up to GitHub to initialize some of those policies and push it out. Okay, so that's going up to the cloud, being applied, and you can see there locally, cluster 1 picked it up, and cluster 2 is a couple seconds behind, but it also picked it up. So what happened there is the pods that we've installed with our system on these individual clusters are constantly pulling that repository, pulling down the whole thing, interpreting the hierarchy there, flattening it out into Kubernetes namespaces, and making all the policy applications. So now I've got all of my namespaces set up. Let's go take a look at it. So if I look at one of these role bindings, and this is the pod creator role binding here, that I've got set up kind of at an intermediate level at the shipping app backend. If I look at that definition, it's pretty simple. It's giving me pod creator role, which allows me to deploy pods on the cluster. And we're binding that to our developer here, Alice at FooCorp. So that's going to give Alice the ability to do whatever she needs to do to manage her application across those three namespaces. If you look at the actual role bindings on the cluster, you can see in shipping dev, right, that it's got three role bindings. And so this is the flattened out version of the hierarchy that we have in our repository. It's got the FooCorp viewers, which is up at the top defined. It's got the pod creator role binding that we were just talking about. And it's got a namespace specific role binding in job creators. So that's what our system's doing, is flattening that out and applying it to all the namespaces across all the clusters. And if we want to test that out, we can pretend we're Alice and try to get some secrets out of Kubernetes. Pod creator role binding does not give me access to those secrets, and so that fails. But if I try to get the pods, that succeeds. Now I don't have any pods, but it didn't fail the auth check. So let's look at the quota. This is the quota file that's in shipping app backend. So it's up there at the intermediate level of the hierarchy. And this is a quota definition that is shared by these three namespaces. It's a pretty simple quota YAML, 3 pods, 1 core, and 1 gig of memory. So let's test that. I'm going to create a pod here with my exciting new application, BusyBox Sleep, and I'm going to ask for about 80% of a processor. So that goes through, no problem. It's less than the shared quota, and now I'm eating up 80% of that shared quota with a deployment in the namespace shipping prod. So what happens if I want to deploy in one of the sister namespaces here, shipping dev? Same image, but now I'm going to ask for 30%. So I asked for 80% before, I'm asking for 30% now. For those of you who haven't been able to do the math, that's more than 1 CPU, and so this should fail. And it does. And what's happening here is we're evaluating the quota at the shipping dev level, which passes, and then we're going up a level in the hierarchy and serially evaluating the quota that's shared across all 3 of these namespaces, and that's where this fails. And so you can set quota in the hierarchy at an arbitrary number of levels here, and we'll enforce it up the chain. And we think this is a pretty cool way to deal with the fact that Kubernetes only natively manages resource quota kind of at the namespace level. If you have sub-team namespaces, but you don't want to deal with portioning out pools of quota across them, this is one way you can accomplish that. And just to show you that it does actually work, we'll try the same application here, but we'll ask for only 10%, and that goes through. So that's quota. Let's set up a new namespace. So let's say we've got a new dev team who wants to come onto the Kubernetes deployments that we've got, and they want a home on all of our clusters. That's fairly simple here. All I have to do is make them a directory and define them a namespace. So I'm going to make a directory locally, which you should see pop into my tree here. So this is shipping app front end, and we'll give the front end team a home. Now that's an empty directory, so I've got to give them a namespace definition, and we'll just set up a simple namespace for them in YAML. So I've got my directory, I've got my YAML, and I'm going to commit that and push it up to the cloud. If you're looking at the bottom there at my clusters, they should pick up that change. And you'll see the shipping app front end namespace there, 6 seconds, 5 seconds, just showing up on the clusters. The great thing about this is I'm only running 2 clusters here, but because all the clusters are pulling down this, you can run this system with one central repository. And as long as that repository can handle the QPS, you can scale this out to as many clusters as you want. So let's take a look at some of these role bindings for shipping app front end. So you can see it's got a flattened out role binding from FruitCorp viewers. That's fine, but it's not going to let anybody on the development team do anything. So we need to set up a role binding for Alice, our developer, so she can get into the front end namespace and start deploying some of our front end applications. So the way I'm going to do that is not to go and define a separate role binding for Alice, because she's already got a role binding for pod creation. What I'm going to do is take the existing role binding, so that's the one that's shipping out backend here, this pod creator role binding, and I'm just going to move that up a level in the hierarchy. So I'm going to take that binding and just say, okay, actually Alice should have pod creation across everything below online in my tree. And so if I just move that up one directory by moving the file around, that should be sufficient to give Alice the privileges that she needs. So I'll push that change. And then if I go look at the role bindings on shipping app front end, I should see, hopefully, Alice's new permission pop in. And there it is, 4 seconds ago, online pod creators. And so just by moving that role binding around in my repository now, it applies to a whole different set of namespaces. And my developers are good to go. Alice can go and do what she needs to do in terms of deployment. And so that's the basics of this. You see the quota can be managed across different hierarchies. You can see a same way to kind of define things once and do it in a way that fits the hierarchy of larger teams. And doing things in the Git way here really allows you to do the GitOps experience of making these commits, validating them, potentially doing a pull request and a review, and kind of sanely checking that across team members to make sure that everybody's happy with them before they're applied and pulled down to the clusters. And then you're only doing it once. And because of the automation that's available here, as well as some of the monitoring and logging that we have that lets you know that changes actually did propagate, you only have to do it once. And if you have made a mistake, right, if you did apply some policies that are problematic for you, all you have to do is roll back. We've got the full history here because it's in a code repository, so I can revert all those changes that I made, roll them back, and push that up to the cloud, and I'm back where I started. It'll kill all of my namespaces because they're managed by Nomos, get rid of all those deployments, and put me back into a state that allows me to roll back to an earlier vetted version of my central policy management. And so that's our demo. We switch back to the slides. All right. So that's basically what we've got for you guys today. The alpha is now open for participation. If you're interested in participating, that's the link there. QR code will take you to the same place if you take a picture of it with your phone. There's just a brief form there. We're trying to bring as many people in as we can. And so fill that out. Let us know if you're interested. Okay, well, thanks a lot for joining us, guys.
Thank you very much.
We'll be around.
Yeah.
And have a great conference.
Yeah, cheers.